Okay, so in this video, I'm going to be showing you guys how to prove that a limit exists and is equal to a certain number using the definition of the limit, the formal definition. So we have that the limit as x approaches a of f of x is equal to L if and only if for any epsilon positive there exists a delta positive such that if you pull x and a close enough together, meaning if the absolute value of x minus a is less than delta, then we get that the distance between f of x and L is going to be less than epsilon, or the absolute value of f of x minus L is less than epsilon. So I'm going to use a simple example. You won't need to do complicated ones in this course since it's just Calc 1, but I do want to kind of establish where this definition comes from so that it's not just stated and then goes away. Okay, so for this one, we want to prove that the limit as x goes to 0 of 2x plus 3 is equal to 3 using this definition. So what we need to show is that for any epsilon that we choose, we can find a delta such that this next part is true. So the first thing that we're going to do is find or take any epsilon. We're just going to take an epsilon. So I'm going to say let epsilon be positive. So I'm just choosing an epsilon. And then I'm going to try to find delta. So what I'm doing now is I'm searching for this delta such that when x minus a, or in this case x minus 0, the absolute value of that's less than delta, then we automatically get that the absolute value of f of x minus L in absolute value is less than epsilon. So let's look at this guy. Let's kind of see what's going on here. So I have absolute value f of x minus L, and I can plug in what these guys are for this particular problem. My f of x is the 2x plus 3, and the L is 3. So I've got 2x plus 3 is my f of x, and this is my L. So I can simplify this, and I get that this is equal to absolute value of 2x. And I want to squeeze this less than epsilon. So we want absolute value of 2x to be less than epsilon. Well, if we choose delta to be equal to epsilon over 2, then watch what happens. We get that absolute value of 2x is equal to 2 absolute value of x. And so long as, so we're going to assume that x minus a is less than delta, and our a in this case is 0. So we've got absolute value of x less than delta. Well, if the absolute value of x is less than delta, then this 2 absolute value of x that we have right here is less than 2 delta, right? Well, our delta we said is equal to epsilon over 2. So this is equal to 2 times epsilon over 2. And when I simplify this, I get that this is epsilon. Now notice that we started at f of x minus L. We plugged in what that was, and we got absolute value of 2x. And then we took this down here, and we were like, okay, absolute value of 2x is nothing but 2 times the absolute value of x. And the absolute value of x is exactly that, the left-hand side of this guy. So then we can say, well, if the absolute value of x is less than delta, or our x minus a is less than delta, then 2 times the absolute value of x minus a must be less than 2 delta. And then we plugged in what delta was, epsilon over 2, and we got epsilon. So this whole chain that we went through started with f of x minus L, and it ended with less than epsilon. And this happens whenever we make the assumption that x is less than delta, which we assumed right here. And that's exactly definition of the limit. So we say, therefore, limit x goes to 0 of f of x, which was our 2x plus 3, is equal to 3. And here, I can fill in this f of x. We've got 2x plus 3 minus 3. And that's our proof.